ചെയ്യണോ ആൾക്കാർക്ക്?
Ma'am, shall we start?
Yes, sir. I'm good.
Okay.
Okay, good morning, everyone. Welcome back to day 5 of our faculty development program organized by Department of Electronics and Communication Engineering of Jyoti Engineering College. We have our resource person for session 9 today. Let me introduce Ms. Jinpriya Ajitados. Ms. Jinpriya Ajitados is the Vice President and Global Head of Delivery Services at Gallant, an AI-native digital engineering firm delivering enterprise-ready AI solutions that transform businesses and industries. A qualified telecommunications engineer with a postgraduate degree in business management, specializing in marketing and corporate finance, she brings deep industry experience from senior roles at Cognizant and TCS. Ms. Ajitados has received multiple awards for sales and delivery excellence across the UK and North America. Her session offers participants a rare industry perspective on where AI is genuinely transforming telecom operations and where the hype ends, a critical lens for faculty engaged in next generation networks research and teaching. We are honored to invite Ms. Jinpriya Ajitados to deliver an online session on AI in telecom hype and real use cases at our faculty development program on advanced communication systems shaping next generation networks organized by the Department of ECE, Jyoti Engineering College. We warmly welcome your gracious online presence and valuable insights to our faculty community. Welcome, ma'am.
Thank you. Thanks for this opportunity. Are you able to hear me, all of you?
Yes.
Yeah, sure. Okay. Thanks a lot for this opportunity. It's a great honor for me to be, talking to so many academicians. My special thanks to the principal of Jyoti Engineering College and Dr. Prajun, the associate professor, and my mentor and godfather of all of my career, Mr. Pati. So, what we are going to talk about this, I'll start sharing the screen, see if you are able to see my screen, and then we'll go from there. Just give me a minute. Is it visible?
Yes, ma'am, it is visible.
Okay.
Yes.
So
Yes,
you
ma'am.
are able to see my presentation?
Yes,
ma'am.
ma'am.
Okay. It's not my full screen, right? Or is it you're able to see the PPT, correct? Full of completely.
Yes, ma'am.
Okay,
It is
sure.
visible.
Okay. So today we are going to do a deep dive into massive shift that is happening right beneath our feet, which is the paradigm of AI. Okay, so everybody talks about AI, but what happens in AI is what, particularly in telecom. Okay, to give you a background, I did my engineering in PSG Tech College of Technology. I'm a 2001 pass out. Then joined TCS, worked for 14 and a half years across the globe for different telco companies. I'm a technologist with a sales and delivery role across the industry. And then I moved to Cognizant, and now I'm I'm taking care of the delivery for a native company called Gallant. We develop enterprise grade platform for AI transformations. That's the background. So after a long time, I'm meeting the academician. So I bring the industry coverage, but I'm not as good as you from academics perspective because I lost touch. in the theoretical space. But I'll give you what is happening around the AI. Okay, so what is happening? The rise of autonomous telecom and what is hype and reality is what we are going to look at in today's session. And so for more than 60, 70 years, the network was managed manually. If you think of managed manually by full room of engineers writing scripts, but now the model is completely breaking under the global data demands because everybody has a mobile phone and everybody streams apps, and the model of telecom has completely changed. So we have moved into an era of autonomous telecom where networks don't just alert a human when they break. They are able to predict the failure, reroute the traffic, and heal themselves. That's what on the current era of timelines we are living in. So over this session, what we are going to talk about is I am trying to break down two things. One is how how in general a telecom system, what we look from industry perspective, and how the machine intelligence and AI is fundamentally reshaping how the bytes of data move across the world. That's where we are going to be. Okay. And now we treat data like oxygen, but we always forget to even think all your high definition video packet. Even now, this meeting, right? The Zoom meeting was actually traveling miles and miles of circuits across with a different traffic. It's a completely different paradigm, but which happens behind the curtain. But what we don't see is when there is a failure. Okay. Once again, trying to, okay. So, okay. So let's see this. I would prefer this session to be interactive so that it's easier for me as well as for you to take away, and for me also to learn from you, from your questions or from the discussions. So, okay, let's quickly think about this scenario. Okay, if you are going to ping me in the chat or raise your hand in Zoom, that's good. But see, Kerala, because you are the region, its own God's own country, right? So you have a good monsoon and all. So how many of you have actually shouted or yelled at your mobile phone when you have lost a web page during submissions, or when you are making a call, or when you are watching a movie? Most of you, right? Most of us, in fact, even I have done that. You know what? There is a famous quote. If I have to say this, we always blame. Telecom is the only industry where the customer blames the company or the telecom systems when it breaches simple law of physics. Okay, so when you are, and what we also do is we always pick up the phone and keep it above us to see whether it reaches a signal, etc. But when we are surrounded by when we are in a concrete basement, or when we are moving across places, or when you are sitting in a dense place with all the greenery and monsoon playing out, we never even think of what we study theoretically, the concrete, the density of the concrete, or the radio wave attenuation coefficients. We immediately think that the system or the mobile carrier or the telecom company has screwed up. No, it is not the case at all, right? So we never think about what is the paradigm around us, what makes the signal stop. So that's how the industry is. So every industry's backbone is telecom. The Zoom meeting is telecom. You go to a hospital, all the MRI scans, everything, all your connectivity is telecom. Go to airline, all the connectivity inside the airport is telecom, in the plane is telecom, your system of booking is telecom. The backbone of the complete industry is telecom, and that's a good and bad part of it, because the good part never gets noticed, the bad part always always gets noticed. So what is telecom in very plain English? Okay, it's about bunch of data. If I have to very seamlessly say, it's every second, it's an unimaginable amount of data that is being routed across when you make a single call, when we strike a web page or anything, right? It is a massive physical machine of infrastructure, which includes concrete towers, underground fiber optic cables, your satellites, and from the front end, your real-time billing system, and all those things. All this infrastructure actually moves whatever we speak. Even this Zoom meeting is being moved as a voice, video, bytes of data between humans, between you, me, and all of us. And it's also getting live streamed, right? So all the movement. But what happens is when there is a downtime. Okay, so the infrastructure is what? You have towers, you have optic fibers, you have satellites, and you have all the systems. We'll see about the systems also, what I speak about. But when everything works fine, nobody even looks, nobody appreciates, right? And when there is a smallest downtime, everybody goes and goes into the internet saying that change of mobile career, or a lot of tweets and all those things happen. So that's the industry what telecom sits on. Okay, so just giving we'll get into serious parts, but still. Okay, so what telecom means? Okay, so telecom consists of two layers. Probably you might all have known. I tried looking at some of your syllabuses as well, but I'll give you a brief what we think from industry perspective. How do we segregate telecom as? Telecom is divided as two systems. Okay, one is the BSS and other is the you are able to see my screen, right, sir? Is my screen visible? I have
Yes,
moved to
yes,
the.
it is visible.
Okay, sure. Okay. Okay. So now that we understand, I'm going to speak about how a telecom company is actually structured internally. To make sense of this massive enterprise, I'll tell you about two parts. One is the cash register versus the engine room. Okay. So every telecom company is split into two worlds. One is the cash register, which represents the commercial customer face. That's where your marketing campaign, all the Vodafone campaign, Reliance Jio campaign, prepaid recharge plans, billing systems, you go enroll, we get all the SIM registration, your OTP coming in, then you get onboarded, then there is a SIM provided, SIM is activated, and then your monthly cycle starts, whether you use a prepaid cycle or your billing cycle. That's where your cash register is. And the engine room, okay, what happens in the background is the engine room or the OSS. The cash register is a nickname what I have chosen, but it is called as BSS system. So that's called as business support systems. All the systems that support the business are business support system that enables the customer to use all the services of any company or any telecom network. Okay, the engine room or the OSS. Okay, what that on the other hand is the deep technical backend network. So when I say deep technical backend network, we can relate to the network radio signal papers what we study in our academics, right? So those are some network hopping, network circuit theory, all those things constitute uh, directly into these networks. So this is the world of physical towers, optical fiber routing, radio frequency, data center, fault checking, then your hardware maintenance. So the ultimate success of any company lies in both the systems, both your OSS and BSS, and how these two interact seamlessly for giving a complete good customer experience to the company, okay, to the end customer, sorry. For example, I might have a I could be a telecom operator, I could have extremely good data fiber network. But if I don't have a proper customer care for somebody walking in, somebody walking in to get enrolled, and my STIM is not going to get registered, probably I won't even get a customer, right? But in case I have a extremely good customer facing system, I have extreme marketing campaigns, I have damn good billing plans, I have attracted customers, but if the network is poor, gone. So both have to work hand in hand, and that's the role of the OSS and BSS architecture. That's where we look at. So if I have to say this, imagine you buy a data top up package or do a prepaid recharge. The moment you click a pay, your payment approval happens. That's where BSS is. Okay, got money. Okay, but after that, after your money is taken, automatically the tower is communicated that your data load, if it is a prepaid charge or if it is if you are in a running customer, you're not due and you're not blocked. That's where the network topology comes in, and when you make the call to locate your specific tower where your phone is currently pinging and instruct the hardware to allocate a high speed data stream. If you're watching a Netflix movie, right? The recent one I was watching, I watch a lot of Malayalam movies as well in Netflix. So if I have to watch it, then allocate me to a high speed data stream network, and that's where the OSS comes in. Okay, and both systems are very required. And I'll talk to you in the end of the session, or maybe 3/4 of the session, on what are the subjects that relate from engineering perspective, what helps in the telecom. Okay. Now we have understood what is OSS and BSS. Okay. In the OSS, before we delve into OSS and BSS, I want to bring you some, explain you some of this architecture from the perspective of AI. Okay. AI can play all, in the whole of architecture, AI can play in a lot of places. We are going to see a lot of use cases, but from BSS perspective, okay, customer support. Are you getting, when you talk to a customer support, in a lot of customer support now a robo speaks. It actually speaks instead of a human, and it actually directs you. Finally, you get an option also, do you want to speak to a human? So that happens, okay? And if you are trying to leave, or if you are a high usage customer, or if you have a plan and your family has in a different plan, are you getting promotional campaigns for a better top-up? Please understand that AI is in place in that. If you are getting an intelligent top-up where you have actually made a conversion of MVNO, or conversion of into another provider. Okay, and consider you're watching IPL match. How does it you are able to watch, as well as your neighbor is able to watch, and somebody sitting in Kashmir is able to watch, somebody is sitting in USA is able to watch. So somebody is working all the rerouting of your network, right? And the reason why there is also AI in play. So if you see this picture, you can see the top layer, the web mobile customer support partners as the top layer, where when you walk into a store, you will actually interact with any of these things. You go into a store, you talk to a customer support team, or you call customer support team, or you can top up via your or a mobile app or your web portal. Okay, then your orchestration layer is where your microservices or your middle layer plays and comes and hits the BSS support system. BSS support system is the one that's actually gives you all the plans, your all your details. Okay, Gina has this kind of plan, and she's on this. She's on a postpaid customer. She's on a prepaid customer. All my details, right? Every detail is there, and what plan I'm there. What can I be improved to? All your product catalog is there. If I place an order for a ringtone, okay, then that goes into order management system. If you can see my screen, and your revenue management and billing invoicing is where I do a prepay on product top up. Probably I will never touch these systems myself. All the request goes from web and hits into the space system. Okay, all done. Now my OSS operational support system comes in. That's where my actual tower entries, what kind of network should be provisioned for me. Am I a 5G customer or a 3G customer? What kind of am I a special bandwidth customer? Should I be provisioned? If I'm on a Netflix, should I be provisioned on a high data network? All your service assurance, all these things, fulfillment happens in the OS system. Okay, and all the intelligence between these systems are secured by the data management layer. We'll speak about when we go into what kind of AI use cases are coming. Okay, and across all these things. So these are the systems, right? So if I'm converting this to IT, all these systems can be, we develop all the software, right? You write a software for web, we develop a software for mobile, we write a software for network provisioning, we write a software for CRM. Okay, all these ones can be automatically deployed into a cloud and spawned across according to the scale, etc. That's taken care by your cloud layer. Okay, so we have spoken about the cloud layer, and the underneath is your data center, your actual device, your tower, your if you next time when you go through a tower, right, mobile tower, watch over, there could be pieces of antennas, and you will see a charger, and on the below of the tower, right, you will also see a structure where there is a small generator and there is a small data center. I won't say it as a data center, but that's the data processing there happens and gets into. All the physical structures are your physical layer network. And all these ones, you can do a zero touch provisioning for your implementation. We can do almost all the pieces can be AI driven. Okay, but AI is not going to replace human. We'll come to that as well. Okay, and almost all the customers, all the companies have gone into cloud. Okay, now we have gone into this. Just a minute, I'm just going to move into the slides. Please stop me if I'm boring. Okay. Okay. You're not able to it's distorted, right?
Heading is.
It's a distorted, right?
Yes. Only heading.
Just give me a minute, okay? Just give me a minute. Yeah, only the title. Just give me a minute. I don't know why it is distorted. Let me open the PDF. Give me a second. This is also a problem from the network, or yeah, it should be a problem from network. Just give me a minute. is fine here. Okay. Maybe it's a problem there. Maybe. Yeah.
Jennifer, I just joined little late.
Hello, sir. Hello, sir. Morning, sir. Thank you for joining, sir. Are you able to see my screen now?
Yes.
Okay.
Can go to slideshow mode.
No, there is a problem when I do a slideshow. Just a minute.
Yes.
Just a minute. No, I had a problem. It's not coming properly. Just a minute, 1 second. Just trying. Okay. Is
Yes,
this
it is
is clear
fine.
now, right? Okay.
Yes, please.
So you are able to see only my presentation, right?
It is visible, presentation is visible, and is in a small tab, your face is also.
Okay. Some problem happened. Okay. So now that we have covered the, sir, we just covered the OSS BSS.
Yeah, please go ahead. Please.
In the previous slide, but okay. So why is now AI coming into picture? Okay, what is the advantage of AI? Actually, AI and machine intelligence will do good for us if we are able to use it rightly. Okay, now that we understand the OSS and BSS framework, what we need to have a look at is why human cannot no longer scale alone in this environment. Okay, in earlier days, the mobile networks, okay, you can have a human engineering team that could sit on a NOC, a network operation center, and watch dashboards for red alerts. And in case there is a tower gone, even in our flood time, petrol was the generator could not happen, tower went down, and all those things happened, right? So if a tower went down, there will be an alarm that would flash, and somebody will be sent. Now, with the arrival of hyperdense 5G networks, IoT smart devices, everybody has a smart device, and it could probably, if you have a Philips, light, which is a mobile control IoT, that kind of IoT smart devices have come now, right? Connected cars and your video streaming, etc. At the single network hub generates billions of telemetry rows and logs, which means that physically it is not possible for a human, for a building full of engineers also, however long they sit and read through of this bytes of data, it is not for us to find out the complex anomalies or react fast to prevent a network slowdown. Okay, the sheer volume, the velocity, and ask from the modern lifestyle of different things is completely physically out of human capacity, that we want some other help that can actually quickly come in and help us out. Um, that's where AI comes in. So you have billions of events. So the network processes bytes of data. And the moment there is an outage, right? every system is now connected. All hospitals have very complex SD-WAN, SD-LAN kind of systems in. So you have a very complex systems running there with the critical ask. If there is a outage, your data center goes out, right? What happens is everything shuts down. And data center can go down not just because of physical constraints, even if there is a lack in optical fiber, it's gone. So ultimately, it's a telecom system. And 24/7, not just from global perspective. I'm not talking about Kerala to US to Chennai. No, just in local per se, 24/7, all networks are required. So the system never rest. They actually don't sleep. And you know how the human possibility is out at that point of time. That's where AI has actually helped human. Okay. Human. Okay. So if you think from a AI perspective, okay, how we see so many advertisements in TV, right? So many advertisements, they talk about AI coming in, speaking about um, either a corporate deck or from your academic point of view or from marketing point of view, everybody today has a picture of glowing brain or a shiny robo with the caption saying it's completely a transformation with the future using AI. Okay, it's very wonderful pitch, but the practical shift is what we are going to talk about, where the AI is actually coming in. It is not just about drawing pretty pictures. It is about how it runs the backend algorithm, how it keeps the complex systems alive, and how actually it saves billions of, I won't say companies billions, it saves billions of people's lives. That's what we are going to talk about in today's. Okay, so coming back, I'm just iterating here and then we move to the use cases. The AI is not a terminator, okay? AI is not going to autonomously run any telecom company or it will replace all the engineers. But AI is going to augment everybody's working style. Everybody is intelligent. It's going to be like assistant to us, okay? Whatever mundane jobs, whatever complex, when I say complex, not from thinking perspective, complex analyzing job, what we are doing, AI can help. But there are going to be a lot of overconfidence from AI. AI can hallucinate very easily. It can give you wrong results very easily. If you keep asking, it gets confused and it shows. So how do you actually eliminate all these things? So reality, it is a statistical pattern, trained pattern on a funny note run by a lot of lightning fast electricity in data center. That's what AI is. How do we use AI for different use cases? It's up to us. But AI is not, definitely it's not a threat unless we are going to get out of it. If we are going to stay in a Neanderthal, Homo sapiens took everybody out in the race. If you have read Sapiens, right? Everybody out in the race and he has forwarded. So how are we going to evolve for the system? What we have built is what we need to look into. Okay, so now. Okay, let's separate the hype from reality. Okay, so when we say AI runs the entire telecom business, no, it does not. It helps operational teams to work faster. What specific work what we need is up to us. What we are going to bring AI into. Okay, AI understands human emotions. We have AIs in the customer facing systems. Does it understand the human emotions? No. Today, go and talk to ChatGPT. Tell it, I like you. Okay, it'll easily give you an answer saying that please understand I'm not a human, I don't have emotion. So it doesn't understand human emotion. So human emotion is still part of human's job. How you relate it when you talk to a telecom customer facing unit, or when we think from the network perspective when we develop the code. So it's all a historical math, prediction algorithms, what we write in here. Okay. Can it replace all staffing engineers? It will not replace all staffing engineers, but it is going to give a total different dimensions of how all the engineers will work. That's the reality. Okay. And going to AI for everything is not at all right. It always because AI is something that we are hearing today, is it always perfect? No, it is not. Absolutely, it is not correct and perfect. We have something called validation. We always do in AI companies. If you go and read about deep evals, etc. So we always check for truthfulness, accuracy, hallucination, and we always give the prompt saying that please don't hallucinate. I do that as well. Okay. So it hallucinates with absolute confidence of something that's not there. Why am I showing you the hype versus reality before going into use cases? Please understand that all of these things are some of the myth what we go with. But all the gaps what the AI is not bringing is where humans should step in. So if we are able to evolve to adapt to some of the factors where humans are required, that's the win-win situation of every engineer that we are going to look at. Okay, let's jump into, okay, what are the focus what we are going to do from per se of telecom. Okay, we are going to look at network operations, where AI can come in and pitch in. We are also going to see the areas of themes of fraud and customer alerts. You would have seen a lot of Airtel ad, right? Charging companies charging, is it right? No, you get, and a lot of spam calls are now addressed by some of the companies and you get a spam, and also on the infrastructure use case. That's where we are in. Okay, so let's get into the real life use cases. Okay, what do you before we get into real life use cases? So all of you, at least from my perspective, you might at least have read about different types of operations in AI, right? So there are two things in AI. One is a Gen AI and other is Agent AI. Gen AI is something, if you think of a Gen AI, it is something as a single task person. Okay, it's like a like author or a one. It's not even an agent. It's you give it a work, you give it a document, uh, it extracts the text. It you give it a content, it reads through the content and gets it. So all your data collection, your coding copilots, and your knowledge assistants, you go to ChatGPT and ask it questions. Okay, any question for that matter, ask about what's the latest movie of Fahad Fazil. Okay, it gives you a list of movies. Where does it takes from? It's the knowledge assistant that goes into thousands of pages somewhere. Either it can be a manual, it could be web pages, it takes, right? So knowledge assistance and code generation. So coming back in telecom context, okay, automated support assist. So Gen A, I said about two types, right? One is the Gen A and the other is Agent A. I'll just flash the other slide also. So Agent K, okay. So Gen AI is something that you give a task and it completes. So that's one part of AI. So somebody on engineering can also do only Gen AI, and Gen AI is the piece where you actually write code on network automation, 5G slices research, all the research on telecom, all gets converted into Gen AI when the research extraction and data model prediction, all those happens. Okay, so that's on Gen AI. The other part is called as Agent K. You might have heard about this word also. Agentic AI is like a manager or like a, head of the institution. That the whole paradigm, how do I orchestrate between two teams, two departments, right? And whole of this orchestration, right? So all that management, orchestration and management and a series of tasks being done to complete one particular outcome is where agent AI comes in. So that's where your self-healing mechanism of telecom networks comes in, your orchestration, orchestrators comes in, your resolution engines comes in. So if you make a call and you get an incoming call, right? You always get a spam alert as well, right? So the number is being identified as a spam by some GenAI system because it has been recorded in some system. But should I go and alert? So somebody is making a call. First, check into the database whether it is a spam call, whether it is a marketing call. And then if it is a marketing call, go and alert that receiver that is a spam call. Okay. So in that, GenAI has come to identify the spam number because it has gone, verified the task, come back. But who orchestrates the whole thing is the agentic AI. That's where, so there are two types. One could be very plain agent Gen AI, where you do all research, modeling, etc. Agent AI is a orchestrate. Okay, all your autonomous rerouting, refunds, and all those things come into picture. Okay. On top, there is something called data. Okay, your data modeling, you would have seen data engineers coming in, doing a big play. The subjects of data structure, algorithms, right? Data reads, all those things, right? All those papers come into play because data is going to be your next oil, or it's already the oil. That's your currency now, right? So the massive data is what helps any agentic AI system or any Gen AI system to function. So there are two types of systems. One is Gen AI, another is agentic AI. Underneath is all your data footprints, which is the data system, which helps in complete modeling and so all the subjects. If I have to relate it, I'll go and relate it in the end slide about what relates from an engineering perspective, because from my perspective, I don't even look at coming out your students coming out just talking about Python. I'm not into that. Unless they really know the domain, unless they really have understood the subjects, there is no point in somebody coming on Python code because they will not even survive in the industry. Okay, so we have got the data also coming into picture. And now let's get into the, once again, why is it not me? Okay, so predicting outages. Just a minute. Once again. Okay. So every transaction, right? Every transaction. Let's what I want to speak in this once again. Just give me a minute. My system is hanging. Okay. So in our traditional books, right, we always talk about how network recovers after a link drop. We focus on, most of you can relate, right, from easy point of view, focusing on routing protocols, calculating alternate paths, etc. So from a company perspective, from the industry perspective, the best outage is the customer never knows. The customer should never know that there was a outage. So can your system so quickly understand how to recover the network after a link drop? Can an alternate path of network rerouting can happen? That's where AI comes in. Okay, so let's look into how it actually works. there is a tower failure. Okay, we had that in one of the flood type. The generators did not work. One by one, the tower went down. There is a hardware degradation that is not even noticed until it breaks. After that, what happens is the user calls or tweets. Then it goes to the customer support. We have all would have done that, including me, right? Everybody would have done that. Then somebody actually understands what has happened. Then they send some person to fix it. Currently, it is not possible for us to do all these things with the number of towers that has come in every area. If you go through, every area has got towers and has got immense cell, right? So what actually happens? Where do you bring AI into this? Okay, AI powered operations has come in, where actually the network signal can be monitored by all your telemetry area data. So what is the drop in signal? Where does your power go? What is your power in the tower? What's your temperature in the data set? Where does your signal drop? Is it a continuous signal drop in particular cell, particular area? Okay, so by this set of data, if I have the data, right? So probably I keep calling in, it happens in my home itself. I keep calling. Some problem happened with one of the towers. It was completely keeping on dropping. Had it been, I am talking about say 5-6 years ago, now it's not happening. Had it been monitored by AI, it would have picked that this person is calling or this whole area, this network signal is dropping. So I have a data right there. And probably we should check that particular tower. So the AI can predict the outage risk in next 90 minutes. Think about if it happens near hospital, which means that your traffic can be rerouted automatically. I have predicted, if I am AI, I have predicted that there is going to be outage near this hospital, which is actually a mission critical. That's a cardiac unit or something like that. The traffic is rerouted and customer never even notices it. That's one of the best use case, I would say, on AI. And it has already started happening. Okay. Second is churn. I don't know how many of you have even know about what is churn is. Churn is we have I consider you have a network, okay, network operator. They keep on having you don't get line. There are network drops. Your voice is not good. Your speed is not good. What happens is you'll start, your friend uses another network. Correct. What happens is you will actually talk about, okay, oh, this plan is good. He's able to reach. You will actually move, right? Churn is something that a customer moves out of one network and goes into the other network. What happens because of that? Actually, the revenue of the company goes down, which means that you're losing you're losing a customer. This also can be predicted. If I know how I am, if the system can know that this user is likely to switch, okay, I don't recharge frequently. I have been using a particular mobile for a very long time, but my top up has gone down or my call itself has gone down. Okay. My Zoom meetings have had frequent drops. That also can be monitored by dropped call data from the tower and from the network, right? And the slow data. I have been either complaining or from my router, from your home router. Home router actually has a lot of automated data that goes back. And in fact, all the self-installation now can be done in your home router, right? Nobody comes in. Very few cases they come in, or they can do all the installation, or we can do all the self-installation. So from the data, somebody can find out. Or you connect a Netflix in your TV. You keep seeing, the concentric circle going on. So it takes 5 minutes to load. So all those data can be actually analyzed by a AI program and say that this customer is having a pathetic experience. So likely that he will go and switch his connectivity. If one person switches, maybe the whole family also slowly will switch, and may not be the same day, but eventually, right? So is AI can flag high risk customer and prompt in value retention? Yes, that can happen, and that's one of the use cases that we use. This is the second use case. Next one. Okay. Most of you now, all of you have used bots, right? So your bank accounts. A lot of us use website, and a lot of us have apps as well. So historically, these bots have been not a automated bot, but a static bot. Example, I'll take an example of Airtel. Airtel has a bot as well, right? So you go into a bot. Historically, 6 years or 7 years back, there were only options. And what it does is, it had 20 options. If you type name, probably it'll do a search and give you a match of name. Now, the bot is actually be able to detect what you are going to ask in first place. If you have searched something in your browser, okay, there is a outage, my speed is less, etc. And you open up a Airtel bot in the page itself. You go to that page and open it. It can immediately prompt you saying that, are you searching for this? Your network status is low. There is a problem and they are rectifying it. That kind of AI customer bots have come into picture now. So before option 6, type to speak to human, or I want to speak to human, the bots have come in to resolve a lot of problems. That's another use case we are talking about. And coming back, this is a BSS use case again. Okay. Okay. So if you remember on IPL matches, when Dhoni comes into batting, what happens is everybody is actually watching the match. Apart from that, everybody starts tweeting. Dhoni is coming in. All the tweets are going in the Insta pictures are going in. Lot of traffics are happening, right? Can you actually balance the speed spikes at that point of time? At that point of time, can you bring in all the resource to focus for that particular peak? And can you dynamically reroute the traffic before the tower collapses or the network drops? It's a massive data. I took a very good example that has happened in reality, and 5G Geo did this. We'll go into those use cases as well. But can AI bring your bandwidth management within between towers and do a intelligent traffic rerouting? That's actually a use case at a network level, at a OSS level, which actually is one of the subjects. We study these things in our ECE or EEE papers, right? Some network rerouting papers and all. So that is exactly are being modeled with the massive data on an intelligent way. This is one more use case what we see in telecom as of today. Okay. This is another interesting use case. A lot of you would have seen network fiber rollouts and field operations, right? So a lot of people come in, route, you will see there is a fiber layout. You move from Airtel to Geo, or take a new connection, or take a ACT fiber network. Somebody lays. If there is no cable in your area, somebody lays and somebody rectifies. You would have seen this, right? So should a agent be sent immediately to the fastest point, or can this be fixed automatically, or can the agent actually stop for a tea, have a chai, and then go to fix the tower? All these things are now being monitored by AI, and told to the agent if he is going physically, saying that, yes, you have some time, you can go. Or it's very, very urgent, it's near a hospital, you have to fix. Those kind of field operations, AI intelligence has come in. Okay. Almost all the call center. Now, when you talk to most of the call centers, right, irrespective of, I'm not even talking about the telecom call center. Every call center is telecom. You call a ICICI Bank, you call a HDFC, you can call a government office. There is a telecaller who talks about it. It is perfectly understand that it is powered by AI. You will have a Cisco or some equipment sitting there that actually is used for taking the call, and the call gets routed. Right? All call centers are telecom. Now coming back, all AI assistants, your client sentiment, I call and say a hello, good morning, and from my tone, the AI is able to predict whether I'm calling in a good mood or in a bad mood. And already I had a problem, I had raised, my ticket is not resolved. So am I going to escalate this, or I'm going to do a by add-on? I can be predicted. All right, all those analysis is now at a fingertip. We don't need to go. If I am a call center agent, I don't need to go, okay, do I have a history of data? This person is calling. She has already complained. She's going to, or she has not complained. She has the very good service. She's going to take another top up. All these data now need not be searched by humans at all. This is all analyzed by AI and given to the human agents who are working. And before coming to human agents, in many of the cases, AI takes the call, understands if it can resolve, it resolves. If it does not, it hands over to human. But all the data is given now. We are writing the code for this. We have implemented, when I say we have implemented, in the industry, a lot of implementations. It's a very, very beautiful use case, very prominent use case. One of the use case that came as a, very long back. This is one of the first of the use cases. Okay. I'm going through the autonomous network roadmap. Again, it's a OSS. It's very much related to your network papers, etc. So instead of routing table, instead of a human working on a routing table and configuring a lot of physical towers, there are physical devices. Okay, all rollouts will happen if you walk around in your street corner, there could be a pop point, there could be a data point. That's also a telecom point. When I say telecom point, it could be a telephonic point, but underneath there will be a telecom point. There will be a pop, right? So instead of all these configuration, routing table, human routing all these things, and human fixing this, complete data analysis and AI analyzing all the data, all the failures, and fixing is happening by the AI. And we have another loop also that's called HLL. You would, when you read about your when you read some of the AI courses and all, that's called human in loop. So what happens is, in some cases, we don't even allow the AI to do the self-healing. So we give it, we introduce a review point as a human. Let a human review whether the decision taken by the AI to heal the network is right or wrong. And if it is right, you say, yes, please proceed. It does the implementation auto repairs without any problem. This is one more use case. Okay, fraud detection. This you would have probably seen in a lot of cases, right? So you have initially what used to happen? A lot of fraud used to happen, a lot of manual KYC used to happen. Now you don't need to do a KYC at all. You do a face recognition, you complete it out. If you fake the face also, it detects, right? And also if somebody swipes the card and manually, or a SIM swap happens, we have to block one by one. Now that is not happening. Most of the companies have implemented AI security shield. So it actually flags any activations with OTP request. You get a OTP request. If it is a spam, it actually tells you. And there is a spam call analytics. When we get a call, if it is a spam, it says that Airtel spam, Geo spam, and then it says about that number. When I say Airtel spam, it's not Airtel spam. Airtel indicating that it is a spam number, which means that Airtel or Jio or BSNL has implemented that this number is a spam. Don't even pick it up. And you might have seen some RBI advertisements and all, right? OTP, the whole money goes off. All those scams are now detected by telecom companies when that is happening at a network level, and they are blocking the user itself. So it's actually the first line of defense for a lot of scammers. That's one very, very good, interesting use case that is helping a lot. Okay. One more case is the green energy. Interest of time, I'll just very quickly go through and then we'll go into last few slides. So from the cyber defense, cyber security, okay. So can I prevent cyber attack dynamically? Yes, AI does that now. AI monitors all your edge level attacks and does that. Can the power be switched off in a data center when the system is not working, or the routing is less, and can it monitor the temperature and do? Yes, that is being done. And also it the bots, lot of AI bots actually actively does the forensic cyber it's called as forensic um, what is that? Forensic evidences, traces all the forensic evidences and actively blocks or prevents all the attackers. Most of the banks, ultimately banks also use telecom company for their networks, right? Most of the banks have implemented this forensic attacks. That's why you don't have a lot of such scams. So new scams are coming in, that's a different call. But cyber crimes are different. Somebody calling and taking my card number is my problem. But what is happening within the network, that has been prevented. Okay. Where does now all the use cases from telecom perspective being completed? I covered most of the OSS network level use cases as well as the customer facing use cases, right? Some of the use cases I've covered. I have not covered a plethora, but I have covered around key cases, right? Where does AI fail? When your data is bad, right? AI cannot do anything. If my base data itself wrong, the AI speaks only based out of data. So I have a data, I'm AI, my data is wrong, I'll give you a wrong result. Second, it has damn good overconfidence and hallucination. Okay. And it keeps repeating the same thing in infinite loops. Even in chatbot, you go and ask some questions, ChatGPT or Perplexity, any Gemini, right? Sometimes it gets into an infinite loop the same way. We have seen this as well. So it relies too much on the trained data. And when I say something is urgent, I've just put it as a small joke, right? So I say my router is on fire. Because of trained data, it says that, yeah, understood. Okay, can you turn off? It was just a joke. It doesn't happen like that, but if you see, AI does a lot of infinite support only by trained data, by training it again and again, recalibrating the model, the AI can be fixed. And that's very key in telecom. Because it's a life supporting system, right? Okay, I'll quickly go through and I want to cover last two slides. Some of the examples where these companies have actually, if you have a Jio, if you have Airtel, Vodafone or BSNL, all these places, AI has already come into picture. Okay, your network optimization. I told you about this Dhoni's coming in. When he comes in, everybody watches the match, whoever is a cricket fan. And Everybody tweets. Insta, there are a lot of photos. See the amount of data that is going through that. So Reliance did network optimization, and that was one of the best use cases that we all actually saw telecom in play. Okay, there are a lot of fiber rollout models they have done with the geospatial analytical layers, uh, giving the best return of investment ROI paths, and also for that's called a GeoBrain platform from from Airtel Spam Shield. It's one of the best use cases you can see on day-to-day life. You get a call, it automatically says it's a spam, right? I don't even pick up those calls. And there are personalized music feeds that are coming in Airtel. If you have an Airtel app or you have a connectivity, all your OTT media is personalized. That's also a very good example there. And also it has done a very good energy management using AI. From Vodafone idea. When I say it's a Vodafone, right? Vodafone has done a very good churn predictor. That's one of the best use case they implemented, and also implemented the outage predictor in by looking at different telemetry data. We saw some of the cases. BSNL is slowly implementing, and the service support has come in for BSNL. Okay, now we are coming to the last leg of the session. I hope I was not boring, but let me, what are the different careers here? Okay, so for sure AI is not replacing any of the roles, but definitely it is going to automate all the monotonous system checking. All your, the engineers can actually focus on what needs to be thought through on architecture, scalability and design. Nobody needs to go through all the logs to finalize. That was a job, right? Initially when we went to bank, it was all written in ledger. Then it went to the files. There also you need to search. Now all those things are gone. That need not be. All the mundane regular job can be delegated. Delegation is a beautiful word you have to use in AI. What can you delegate to AI? These things can be delegated to AI. What do you want to think about? We need to think and ask AI for assistance. So what will be the winning skill set for next set of engineers? Next set of engineers are called as forward deployed software engineers, FDSE. When I say FDSE, I'm talking from the market perspective. I'm talking from the day to day. They should know what domain they are going to work in. Not day one they join, they may not become an expert. They should be very, very, very quickly should be able to scale up. That's one. Second is, so they should have good communication skill. Communication skill doesn't mean that it's only English jargons. They should be able to talk the language of the other, listen and reciprocate what the other person speaks. And how do you respond to it? And so we have covered communication, we have covered the domain. A domain is, when I say domain, we will think of from college, how do you get domain? If somebody has learned the network so well, right, probably they'll understand how the tower fails, how the network rerouting happens, how do you actually do the network hopping. If they are able to understand this, definitely if they go and work for a network company, for example, Ericsson, and they work on networking, a rerouting table algorithm, they will understand. That's called domain. So the subjects are very important. And also on top of it, the skill of coding. So the foundation from coding per se would be, from a perspective, I would say all the standard APIs, all your networking papers, digital engineering, and also Python. Okay, and Python is not the mandate. Python, and there is a term called polyglot engineers. Polyglot is somebody. See, when I started my career, I'm a Java J2E. Then I moved and different skills I acquired, right? So you had somebody on a Java will only do Java. Somebody on .NET will not do Java, and Java will not do .NET. Now that is not the case. Coding is out. Development is out. What we are looking at is something called polyglot engineers who can actually scale up in 2 days. Literally scale up in 2 days, because go and ask ChatGPT, will give you a code of .NET. ask it in Java, it is going to. What is our intelligence to scale this up? Are you able to scale up in 2 days to understand this code and you are able to review the code and do, right? So learning a coding skill is easier, much, much easier. It is not as difficult as it was 15 years ago. The gap is the domain skill in the market. Okay. Okay. And now, before we go into the last bit, who actually builds telecom AI? Okay. All the operator companies, right? Trio. So from the placement perspective, when I say placement, not just a job perspective, I'm talking about, so we are all pushing out, even I'm, I'm working with all the youngsters, right? Gen Zs are there. Millennials are my architects now, all the 90 bonds. And a lot of professors also would be 90 bonds, and 2000 bonds also could be there, all pass out new Chinese. We deal with a lot of millennials and Gen Zs who are going to be the future, and next set also is coming in, right? Your alphas and betas are also coming in after 2015 bonds. All will come and assimilate. I'm not talking from a short-term career perspective. I'm talking from a long-term career perspective, which will actually give you a sense of pride, what I have done in the job, what I have delivered. If I look back, okay, these are the things I have done. I have a story to tell. Not about, okay, I got a pay rise. I bought a house. No, am I proud of myself? So I'm talking from that perspective. If somebody wants to pursue telecom industry as a career with the AI, all the operators, right? Jio, Airtel, Vodafone, Idea, BSNL, all those work on 5G spectrum, customer data, physical networks, and all those pieces. Okay, all the IT powerhouse build all the integrators. They do all the AI ops, BSS systems. They do all the support bots. They do all the when we talk about all the order management system, all the interfaces that has to be built for these operators are done by IT powerhouse. All the most of the IT companies. And all the complete infrastructure lies on cloud. So in all these pieces, the telecom implementations lies. So this is where the paradigm of career, one can work in all the three, right from integrating from cloud to IT system to the end tower, or can specialize in one of them. So I just want to talk to where, okay. Where are we looking at? One second. Okay. So when I talk about industry ready, okay, what students should master. Okay, a lot of us think that IT, when they come into IT or any career, they switch career, they enter into career, we are looking only for Python coding or a C++, Python coding or, Perl scripting or no. All your basics are very, very important. And in particular, because this is a telecom session, right? I'll just iterate about telecom. All your computer networks, data communication, wireless networks, telecommunication management systems that covers your routing, OSS, BSS workflow, etc., are very, very key for being domain expert. The person who comes out need not speak the industry language, but should know the fundamentals if they need to operate at a industry level. That's one. Second, the programming for engineers, right? Some of the papers we will have for programming for engineers, Python, most of the colleges might have. There could be some cloud courses and all those things. Apart from that, there would be data structures, algorithms, because they are all needed. If you want to do AI modeling, somebody should understand how the data structure works. How do you actually work on the algorithms? How do you actually do the cloud computing? All those basics are required. Only then it translates into a meaningful coding. And then comes the next gen architecture, where a lot of papers on advanced AI. Software architecture is very key. That's a gap I see in the market when I talk to some of the young engineers, right? It all has come as AI or people coming and just coding. Software architecture, system design, and then the AI specialization. This is if we are able to get a student cover all these three, at least at a basic level, right? Then I think we all can be very proud that they will survive they will thrive. I won't even survive. I won't say thrive. They will thrive and shine. That's where I see call for action for all academic institutions for bringing these things. So again, AI will not replace the engineers, but how does somebody leverage AI will be the one who will survive. That's all. Thank you.
Thank you, ma'am. So we can open this floor for a brief question session. Dear participants, this is your opportunity to ask the questions. Participants can share the questions through the chat box, or you can raise the question using raise hand button. So we will unmute you. I think there is one question in the chat box.
Can you read the question? I'm not able to see that. I did see that, but
what skills should engineering students develop to pursue careers at the intersection of AI and telecommunications?
okay. That was the last slide that I covered. So all your telecom fundamentals, right? Once again, I'll just all the. So what I see from AI perspective, the coding could be probably Python, and it could be a full stack. It needs to be a full stack. Either you pick up a Java or .NET, doesn't matter, because we look for polyglot engineers who can actually switch different languages into. So Python and all these full stack, either one of the stack is from coding perspective. But if they want to enter into a domain, in particular, we are talking about telecom, right? I'll talk about telecom and I'll also talk about few other domains as well in general, because from my company perspective, we develop platforms for several other, for a lot of domain specific cases, right? So from telecom perspective, for when I talk about what are the skills from domain, it has to be computer networks, data communication, wireless networks, your telecommunication management systems, where we talk about rerouting, routing, SIP diameter protocols, OSS, BSS, inventory systems, etc. And from the algorithm and data per se, data structures, data algorithm. This is from domain. From AI perspective, it could be Python plus any of the full stack, Java J2E or your, Java or your .NET stack. That's where we look at from the skill set per se. This is from telecom. I'll just give you one more 2 cents from other domains. Whatever the domains are, okay. So telecom probably we cover in easy. If you are getting into, if somebody is going into a mechanical engineering, they do a lot of infrastructure, right? Stress testing and loading. All the domain specifics needs to be there if somebody wants to thrive in this industry. AI will bring you the coding perspective. What does the human bring in? Human brings in the knowledge of domains. That's where we are. I hope that answers the question.
Any participants, if you have any doubts, can share in the chat box. We have a few more minutes. Ma'am, we have one question. Which emerging AI technologies do you believe will have the greatest impact on telecom sector over the next 5 years?
6G and AI injected monitoring systems. That would be the that will bring the greatest impact in next 10 years. Because that's going to completely change the way we are interacting. The speed is going to become huge. If the speed is going to become huge, what is the amount of data we are going to consume is going to be immense, which means that our knowledge base is going to increase. That's where we are looking at.
Thank you, ma'am. Now we can conclude. Thank you for your generous responses for all the questions. On behalf of the Department of Electronics and Communication Engineering, so the Engineering College, and on behalf of all our participants, I extend our heartfelt gratitude to Ms. Jinapriya Ajithados for this truly enriching session. We wish Ms. the very best in all your future endeavors, and we hope to have the privilege of your presence and guidance again. Thank you, ma'am. Thank you very much.
Thank you. Thanks a lot, ma'am. Thank you, Principal Sir, Sojan, Dr. Sojan Sir, and thanks a lot for this opportunity.
Thank you, ma'am. Now we will go for a short break and we will come back at 1 p.m. So participants are requested to join before 1 p.m., preferably 12:50. So thank you all. We are privileged to have Dr. Bindu K. Rajan as our resource person in the next session. Thank you all.